Today's lesson is going to be over converting fractions, decimals, and percents. And my pen is dying. Let me switch pens on y'all. Converting fractions, decimals, and percents. Okay? In the math world, you're going to hear a lot of people refer to this as FDP. F from the fractions, D from the decimals, and P from the percents. So you might often see me label things on your Google Drive as FDP, or you might even hear me refer to them as FDP. That's what we're talking about. So we talked about how fractions, decimals, and percents are the exact same representation of a number. They're just different ways of looking at it. So today we're going to practice being able to do those fluidly. So the first thing we need to do is to make a foldable. Now some of you are going to be using your paper foldable with me, and others of you are using the interactive notebook. The interactive notebook has already got your setup in there. I provided it for you and you should have added it already. It is the one that you added 4 pages at a time, and it had the links to take you to multiple pages. Those of you who are using paper, I'm going to help you get this set up. So what I've got here is just a regular sheet of paper. It is green. It works just as well as if you have just a regular white sheet of paper as well. But what I happen to have at home was green paper. So I've got this laying long ways. This is horizontal. I know it's hard for you to tell. So this is vertical, horizontal. I've got it horizontal. And I'm actually going to fold it in half hamburger style to get it set up. Okay. So you can see that it is hamburger style. I'm going to open it up and we're going to create what we call a shutter fold. A shutter fold is when you take your outside piece like this and you fold it into that crease you just made. Okay. There's one. And the reason it's called a shutter fold is because it creates like shutters like you would have on a window. And I'm going to do the other side into the crease as well. Just like that. Okay. And then you're going to cut this into 3 pieces, okay? You're going to start with the shutter part. Don't start at the crease part. If you cut the crease part, it will tear it up. So you want about 3 equal pieces. Guys, it doesn't have to be perfect. There's 1 and 2. So you see how I've cut that flap into 3 pieces. Okay, I'm going to do the same on the other side. And I'm just going to try to line it up the best I can. And the way I'm going to do that is line my scissors up right, you see, right where I cut it, like that. And go to the crease. And do the same thing over there. Okay. So now I have successfully created the template for my foldable. Alright, so on my foldable, the first part that I want to create is going to be percents to fractions. So I want a P, an arrow, and an F. So percent to fraction. So in order for you to convert, the word convert means to change or exchange. In order for us to convert percents to fractions, there's a rule. You're going to place the percent over 100. That's step number 1. Okay? Just place it over 100. Step number 2 is to simplify. That's y'all's least favorite part right there, is to simplify. So I'm going to put an example over here for you. EX does abbreviate example. So if I have, we're going to say 24%, just like that. The first thing I'm going to do is place it over 100. So I'm going to do 24 over 100. Okay? Now the next step is to simplify. Well, to simplify this, we're going to divide by 4. Okay? 24 divided by 4 gives us 6, and 100 divided by 4 gives us 25. There is my simplified fraction. 24% is the same thing as 6 over 25. Have no worries, we're going to practice this plenty here in a minute. Right now we're just getting our rules written down in our foldable. So those of you who are keeping the interactive notebook at home, you can insert text boxes to type this in to your foldable. So whenever it takes you to that second page and you have what looks like half a page to be able to type, you can do this and you can show this work. Okay? All right, so for this side, we want to know, how do we go from a percent to a decimal? Percent to a decimal. So this is the one that's actually a little bit easier. Step 1 is divide by 100. Remember, percent is out of 100, and a decimal is out of 1. So to go from 100 to 1, mathematically, I want to divide by 100. Okay? So we're going to take the same one we just did, so 24%. So I'm going to do 24, and I'm going to divide it by 100. Well, 100 can't go into 24, so I'm going to add a decimal and 2 zeros. So 100 can't go into 24, but it can go into 240 2 times. Bring down our 0. 100 can go into 400 4 times. And there's your decimal. Okay. And this over here was just some helpful notes. Okay, so those of you at home using the interactive notebook, you can add text boxes to this section of your foldable. Okay, the next one that we're going to look at is going from a decimal to a percent. So to go from a decimal to a percent, well, let's look up here. To go from a percent to a decimal, we divided by 100. So now we're going the other way. So what would the opposite of divide be? Multiply. So we are going to multiply by 100. Okay? And remember, over here, I'm going to leave a note. Decimal is out of 1. And percent is out of 100. So if I'm at 100, so I'm at if I'm at 1, sorry, because I'm at the decimal and I'm moving to percent, I'm going to multiply by 100. So let's go from 1 to 100, I'm going to multiply by 100. So here we're going to use the same exact fraction, or the decimal. We have 0.25. And we want to multiply by 100. So 4 times 0 is 0, 4 times 0 is 0, 4 times 1 is 4. Put our 0 into place value holder because we're moving over to the tenths place. 2 times 0 is 0, 2 times 0 is 0, 2 times 1 is 2. Add them all up. And now we need to place our decimal in the correct place. You have 2 numbers behind a decimal in the problem, so you're going to have 2 numbers behind the decimal in your answer. So you can see right there, your answer is 24.00. Remember, we have no need to write the decimal with zeros behind it, so your answer is 24%. Let's go ahead and look at decimals moving to fractions. Okay, for a decimal to move to a fraction, you want to call the decimal by its name. I didn't say call it names, I said call it by its name. So if we have the decimal 0.24, well, that's the way we say it when we're just trying to clearly let everybody see what we're talking about. But the correct way to say it, the mathematical way to say it, is 24, and then you say its place value. Its place value is hundredths. So here's our decimal, so this is tenths, and this is hundredths. So listen to how I say it, 24 hundredths. So 24 hundredths. So that one is done that easy. Let me show you some examples also. So this would be 3/10. Listen to how I said it, 3/10. 1 and 12 hundredths. Listen to how I say it, 1 and 12 hundredths. Forty-seven hundredths. Listen to how I say it, 47 hundredths. Call it by its name. Last row, our last row, we are going to do fractions to decimals. Now this one you did in 5th grade. You had lots of practice on it in there, so we're just going to write the rule down for it. To go from a fraction to a decimal, you're going to divide the numerator by the denominator. Okay. So let's say we have a fraction of 4/6. No, let's not do 4/6. Let's do we'll do 4/5. Sorry about that. I don't want to give you 4/6 right now. We're not ready for that one. 4/5. Okay, the numerator is your top number, and your denominator is your bottom number. So there's denominator, and here's numerator, just like that. The numerator is being divided by, so numerator goes inside the house, denominator goes outside the house. Always go ahead and add a decimal and 2 zeros. 5 can't go into 4, but 5 can go into 40, so it goes above the 0. 8 times 5 is 40. Subtract it, bring down your 0. 5 goes into 0, 0 times 5 is 0. So there's your decimal. And last but not least, today we're going to look at fractions to percents. Fractions to percents. Okay. Step 1 is divide the numerator by the denominator. Step 2 would be multiply by 100. Okay, so we'll do the one that we just did, 4/5. And so that brings us to 4 being divided by 5. And we got 0.80. See, right here. I didn't skip a step on you. I'm just not rewriting the actual word. 0.80, and now we're going to multiply by 100. So 100 times 0.80 Oops, sorry. Two numbers behind the decimal in the problem, so we're going to have two numbers behind the decimal in the answer, giving us 80, which makes it 80%. So there's your answer. Okay, have no worries. We are going to practice this. You do not have to memorize this as of right now. So if you are keeping a paper copy of your notebook, this is where you will glue this in. Okay? If you're keeping an interactive copy online, yours is already inserted in. You just need to finish filling it out. Okay? So it will be glued in right there. So now let's get some practice in on converting these numbers. So I'm actually going to have you use your book, your digits book. It's going to start on page 407, page 407. So I'll give you just a second to find that. On page 407, we're going to look at the first sample problem. So what we see here is the results of an international origami competition to show how many animals' top folders perfectly folded in 50 minutes. How could the origami competition organizers use fractions, decimals, or percents to better represent the results? So when we're looking, what we see is we have the happy friend folded 8 perfectly folded origami animals out of 12. So he attempted to fold 12, but 8 of them were perfectly folded. And you can see the surly friend had 6 of them perfectly folded out of 10. The new friend was 4 perfectly folded out of 8. And not a friend was 10 perfectly folded out of 15. So when we first look at this, it looks like not a friend did the best because he got 10 perfectly folded. But that was out of 15. And if you look, each of the other competitors did not do 15. They did different numbers. So we have to see what is the percentage of those, or what decimal was the correctness versus what they did all together. So we're going to set these up as fractions first. So I'm just going to extend my column right here, and I'm going to write an F right there. So my fraction for the happy friend is going to be 8 over 12. For a surly friend, it's 6 over 10. New friend would be 4 over 8. And not a friend would be 10 over 15. Okay? And we want to know what is the decimal for all of these. So you have space around your paper that you can do some work. So I'm going to start with happy friend. I have 8 over 12. The first thing I'm going to do is I'm going to reduce this. It's going to be a lot easier for me to work with if I reduce it. Most of you are going to say divide by 2, so we can do that. That would bring us down to 4/6. You can either work with the 4/6 or you can divide by 2 again if you'd like. So 4 divided by 2 is 2, 6 divided by 2 is 3. So I have 2/3. So now I'm going to take 2 and divide it by 3. So 3 goes into 20 6 times. 3 goes into 20 6 times. Uh-oh, what's going to happen? 3 goes into 20 6 times. It's going to repeat, isn't it? Over and over again. So we call this a non-terminating decimal. It means it doesn't stop. So in my classroom, once you get to 3 numbers, I tell you you can stop. And I want you to round it. So this would round to 0.67 because this 6 right here is going to make this 6 right here raise up to 7. So it's 0.67. So that was for the happy friend. Now let's look at the surly friend. We have 6/10. Remember, if you can reduce, go ahead and reduce or simplify. And that's going to bring us down to 3/5. So I'm going to divide it out. 5 goes into 30 6 times. 5 goes into 0 0 times. So for the surly friend, it's going to be 0.60. All right, let's look at the new friend. 4 eighths. 4 eighths reduces to 1/2. We should know what that one is, but just in case you don't, I'm going to divide it out for you. 2 goes into 10 5 times. 2 goes into 0 0 times. And then our last one is not a friend. So we're going to look at 10 15ths. I'm going to divide by 5 to reduce it. So it gives me 2/3. Does that look familiar? What did we find on 2/3 earlier? It was 0.67. So save yourself some work. Okay? So let's look back at the question. It said, how could the origami competition organizers use fractions, decimals, and percents to better represent the results? So what do we find? Well, we find that the happy friend and not a friend actually folded at the same accuracy. And we found that new friend had the lowest accuracy, and surly friend wasn't too far behind happy friend and not a friend. Okay? So earlier we were talking about converting decimals into percents. And I told you that you're going to multiply by 100. Well, when we're multiplying by 100, we're adding 2 zeros. If you're adding 2 zeros, it means that the number is getting 2 place values larger. So all you're going to do, let me switch colors so you can see what I'm doing here, is you're going to move it 1 0, 2 zeros. So that now gives you 67%. Right here, we're going to multiply by 100, so it's adding 2 zeros or moving 2 place values. So we're going to move it 1 place value bigger, 2 place value bigger, and that's 60%. And down here, we're going to move it 1 place value bigger, 2 place values bigger. So that gives us 50%. And down here, because it's the same, we know it's going to be 67%. So as you can see, decimals and percents are obviously the easiest ways to be able to see information more clearly than it is in the fraction form. Okay, let's look at the reflection. Would you rule out using any form of these representations, fractions, decimals, or percents, to improve the results for any reason? If so, why? So we just said that it is harder to see the difference when they're in form of fraction. It's easier when they're in form of decimal or percent. So go ahead and turn it over. So here we go. On an 85 question multiple choice exam, a student got 71 questions correct. What percent of the exam did the student get correct? Round to the nearest whole number or whole percent. So how many questions were there total? So the whole set of questions was 85. And he got 71 correct. So our fraction is 71 over 85. If we want to figure out what percent he got correct, we can look back at our foldable, and our foldable is going to tell us how to go from fraction to percent. So when we open it up, we see that we have to divide by the numerator, or divide the numerator by the denominator, and then multiply by 100. Okay? So I'm going to turn my paper sideways so I have a little bit more space. I'm going to put 71 just like that. And here's 85. All right, so I have to figure out how many times 71 can go in, or 85 can go into 710. So 85 plus 85, or let's do 85 times 5. So that's 425. Let's do 85 times 8. 64, 68, that's 680. So if I added 85 more to that, that would be 765. So that's too much. So we want to do 8. And we know that that was 680. I'll bring down my zeros. 85 goes into 300. We know 85 times 5 was way too much. So let's do 85 times 3 and see what happens. There we go. It is 3 times. So we have 255. So 45 is left over. Okay. I'm going to add another 0. So right here, 85 times 5 is 425, so we're going to put a 5 there. And remember me telling you that once you get to 3 spaces, I allow you to stop. So this is 0.835, which would be 0.84 once we round. Okay, now I'm going to look at the question again. It said round to the nearest whole percent. We're wanting it in percent. So this is in decimal form right now, so we're going to multiply by 100. So we're going to add 1 0, add 2 zeros. So it would be 84%. Okay. All right, let's look at the second part of that question. So on an 85 question multiple choice exam, a student got 71 questions correct. When might representing the result as a fraction, a decimal, and a percent be useful in analyzing this situation? Well, representing it as a fraction was helpful because you could see how many he got correct out of how many total. Doing it as a decimal helped us to see what his accuracy was. And then once we had it in a percent, we could actually see his grade. We typically give you grades as a percentage. Okay. Part 2. A koala sleeps about 75% of the day. Write the ratio of hours a koala sleeps per day to the total number of hours in a day. So he sleeps 75% of the day. And we want to know it as a ratio, so that would be as a fraction. So the first thing we're going to do is we're going to turn this into a fraction. So 75 over 100. And then we're going to simplify. We can divide this by 25, giving us 3/4. Okay, so here's our new fraction. If we wanted to know what it was in a real day, well, let's bring it over here. How many hours are in a day? 24. Sorry, I didn't mean to write it like that. 24. What do I do to 4 to make it get to 24? Well, I multiplied by 6, so I'm going to multiply by 6 up here. 3 times 6 is 18. So for 18 out of 24 hours in a day, the koala is sleeping, and that is 75% of his day. Okay. I am going to allow you to work from here, and there's a couple of assignments that you're going to be using. So let me see if I can get my screen to switch over for you. I'll rotate it around. It does not like that. Hang on just a second. Okay, so what you're going to get is a paper that looks, let me get there. You're going to get some papers that look like this, but you're going to get them in form fashion. So it'll just have a picture and you're going to type in your answer. You're just going to be practicing going back and forth with decimals, fractions, and percents, okay? After you are done with that, you're going to get an activity. Let me find it so I can show you. You're going to get something that looks like this. and it's got some task cards on it. And you're going to be able to record the task cards on the screen. And they look like this. So you'll just be able to type in them and write on them. Okay? I hope that that was helpful. Thank you for coming to lesson.